What is our place in the universe? Was planet Earth created specifically for intelligent human life, or are we a cosmic accident? Today we'll discover why Earth is truly a privileged planet. Hello, I'm Eric Sam, your host, editor-in-chief of Crisis Magazine. Welcome to Crisis Point. Before we get started, I just want to encourage people to hit that like button, subscribe to the channel, let other people know about it. Also, we only do this 2 times a year. We're doing it right now, which is our fundraiser, our twice-a-year fundraiser. Go to crisismagazine.com. You'll get a pop-up that'll ask you to donate. We really do appreciate any donations. All of our content is free, but obviously it's not free to produce. So we do appreciate that. And we promise not to bug you until probably maybe May or June. We'll give you about 6 months before we bug you again. But we're doing great on our fundraiser. We have a great matching grant, $75,000, and we're getting closer and closer to matching that. So I appreciate everybody who's already donated. Okay, so today our guest is Jay Richards. He is a returning guest. We always love to have him. I feel like he has a plethora of different interests, and all of them seem to align with mine, so it works out. He is the William E. Simon Senior Research Fellow in Heritage Foundation's DeVos Center for Religion and Civil Society. He is a senior fellow to Discovery Institute and the co-author of The Privileged Planet, How Our Place in the Cosmos is Designed for Discovery. And it just came out, hit my microphone there, just came out with the 20th anniversary edition. I had the old edition, and Jay was nice enough to send me the 20th anniversary edition. And it's an excellent book. We kind of want to talk about the themes of that book today. So welcome to the program, Jay.
Eric, thanks so much. And I was looking forward to doing this because I know you're an amateur astronomer yourself, so you're interested in this stuff.
Yes, exactly. I'll try to control getting too geeked up, I guess, for those who aren't as much. But yeah, no, I take that back. I'll get geeked up.
That's what this is for.
Yeah, right. Exactly. What's the point of the podcast if I can't get geeked up about it? So I want to start with something I think you start with in the book, which is this year in 2024 in America, we were able to have a total solar eclipse. Yes. And I was very fortunate. It was over my house. I did not have to go anywhere. I barely was in it, so I didn't have a long time. I only had about a little bit over a minute. But I was weighing, okay, would the extra 3 minutes or so make up for the fact that like it's going to be a disaster driving somewhere in the traffic and everything? My mom literally, she was still alive at this point, and she's only about 12 minutes away. She was going to come over, and she was outside of it. That's how close we were to the edge. Yeah. She was going to come over, and it was all back roads to her house. And literally, she got about a half mile, and it was so backed up, she just turned around. And she's like, it's not. And I felt bad because what I should have done was picked her up hours beforehand, brought her over, and then. But that's on me. But anyway, the point is, the eclipse was awesome. It was. Yeah. I had read so much. I read your book, The Privileged Planet, and other things about how great an eclipse is. But everybody said it's not just, you have to experience it. And that's right. Everybody's right. Because it's so true. It's so different when you experience it than when you read about it or see a video of it or pictures of it or anything like that. It just, there's something, my wife, she's a little bit more better at expressing herself than me, but she really was like, there was something about the light that shows during an eclipse. Yeah. That she felt like it was almost like the transfiguration light. Like it's this pure light that you just never experience, and there's just something about it. And I'm leading to a question probably at some point, but it was such a great experience. Now you went to Dallas, right?
Yes, in fact, yeah. And so the very first chapter of our book is about eclipses, and the argument in the book is that the things that make a planet habitable in the universe, those ingredients you need to build a planet that can host life of really any sort, those are also the best places overall for doing science and making scientific discoveries, so that observers find themselves in the best place for observing. And solar eclipses sort of figure prominently, I would say, in the book, because we take it for granted that our moon and sun, their apparent size is the same in the sky, that, these two completely different bodies, but they very round, sort of visually from where we are, and these things align. We shouldn't take that for granted. My co-author, Guillermo Gonzalez, years ago, right before we started this book, actually did a study of the other planets, the 65 major moons around the other planets, and found that really the only place in the solar system where you get these is right here on Earth. But as you said, I mean, you can spend, and we do spend a lot of time on the sort of mechanics of that, but the experience of a total solar eclipse, you just can't replicate it or describe it. And I very often will hear people saying, oh yeah, well, we saw most of it. And I say, look, if you saw 99%, the difference is between day and night. You just didn't see it, because it's only when you get the disk of the moon covering the bright part of the sun called the photosphere that you can actually look at it with the naked eye. And so what happens is that just as it passes into what's called totality, you can suddenly, you take the glasses off, you can look straight at the sun and the moon, and now all of a sudden you can see the solar corona, the outer part of the solar atmosphere, which is, it's very ghostly and ethereal. You cannot see it when the sun, when you're seeing the bright part of the sun, but it looks very much like an eye in the sky. You've got this black pupil circle in the middle, and then you've got what looks like a kind of gray iris, and then darkness. Like in Texas, we were in Waxahachie, Texas, south of Dallas, specifically picked that place, and Discovery Institute hosted an event because it's right in the center of totality. So we had 4.5 minutes. I can tell you, you get 4 minutes, your eyes adjust to things. And so you're seeing the darkness, you're seeing the kind of outer atmosphere of the sun that you cannot normally see. We were able to pick out the three planets, actually, and a couple of bright stars. But what's weird about it, unlike during the night where everything's dark, if you look in every direction around the horizon, 50 miles out, the sun is shining there. And so that's what's just, you can't describe it. Absolutely everyone that experiences it directly, I've never heard someone say, well, that was kind of cool. It's always like,
Right.
That's one of the wildest things I've ever experienced in my life. And it really is.
Yeah, there's just something very surreal about it. My daughter actually lives in Dallas, and so she was keeping me updated. Like there was worries that it was supposed to be cloudy potentially, and she said just literally it was almost like God just said, "Okay, we'll give you take away the clouds for a minute so you can have it," and then it's like it was amazing.
In fact, I should probably tell this story. I've never told it publicly, but here goes. We picked Waxahachie because of where it was. We thought it's high probability of being sunny. And as you said, it was socked in the Dallas area. I mean, it wasn't just cloudy, it was murky. And we had to drive from our hotel in Dallas that morning for the eclipse. And Guillermo and I, my co-author, we were supposed to sort of do running commentary for this crowd of 750 people that came, talking about what they were going to see. Well, at 9 that morning, there was nobody seeing anything. I was seriously panicked. I was in a depressive funk. I couldn't get out of the car. And my wife's like, okay, well, I'm just going to go pray a rosary around the area. And so she did that. And so I must confess, I was so afraid that all these people had come all this way. I promised God that I would do something, a very long fast. I don't want to sort of over describe it, but I'm Moses or something. I'm just bargaining with God at this point, anything. But it was kind of a big promise. And so, as you said, it was cloudy. And all I really prayed for was that people would be able to see the totality. But even right as the eclipse started, right at the edge, the sky parted. It was so clear that we ended up with sunburn when it was all over. Wow. And then the next day in Dallas, my daughter's at the University of Dallas. I'm in Dallas. It's so murky at noon that the street lights were on. So that was like, that's the backstory. That's what's happening. And then the skies parted. So I just, honestly, it was amazing.
Yeah, that it is. Now, the thing is like, yes, we're super geeked up about this. It's very exciting. People who've experienced it know what we're talking about, and people who haven't, there's not another one in America for a long time, but goes. My daughter, literally, the one in Dallas, is literally thinking about going to Iceland for I think it's in 2026 or something like that.
Yeah, that would be a cool place to see it.
Yeah, and that's what I thought too. But like, it's more than that. Like you mentioned that it's a quote unquote coincidence that the moon is the same size visually the same size as the sun in the sky. And so we can have this opportunity where it's literally just right there perfect, because if it was bigger, then it would cover up. We wouldn't see things as the corona, all that stuff. If it's smaller, then it's just like a partial eclipse, which is like nothing.
Yeah.
And, but it's exactly right. But now what's amazing is in scientists have actually used that to make scientific discoveries because of that. And I know the most famous one is, I think 1919, is it, from proving Einstein. So why don't you explain a little bit how an eclipse scientists actually use it to prove scientific, theories?
Yeah, absolutely. And so just to back up a bit. And so our book is about this remarkable, I think it's a conspiracy rather than a coincidence, but the remarkable things that if you look at the things you need for a habitable planet, it turns out those provide the sort of amazing opportunities for doing science. So in this case, one of the main things you need on a planet in order for it to be able to host life is it needs, first of all, to be around a star with an energy source, but to be the right distance from your host star. So the Goldilocks zone, not too hot, not too cold. Too close, you're Venus, right? It's 800 or 900 degrees Fahrenheit. Slightly too far away, you're barren Mars. So that tells you, you got to be just the right distance for a planet to be able to have liquid water on its surface to host life. Well, now that's not surprising that that's where we are, obviously. That's if we weren't there, I wouldn't be here talking about it.
That's right.
But think about that. So when you get to Goldilocks zone, for the right distance for life, that's going to set the size of your sun in the sky. Another thing that you need for complex life on a planet like ours is it turns out you need a large, well-placed moon like we have. If the moon were not there, the tides wouldn't do what they need to do. The Earth would wobble on its axis erratically. It would just be, really catastrophic for surface life. But so when you get a moon in the right spot, in the right size, that's going to set its size in the sky. And when you get those two things, you get total eclipses. So that these two things needed for observers on the planet, right, also set up conditions for this cool thing, eclipses. And then, as you said, eclipses aren't just cool. They are like natural experiments set up for astronomers to be able to test things. The most famous example of this is the eclipse expeditions in 1919. So Einstein had proposed his general theory of relativity, which is basically a kind of a theory of gravity, but it's in some ways it's a theory of everything. How space, time, gravity work in the physical universe at large scales. And so one of his predictions is that if you're right, so rather than thinking of sort of gravity as an attractive force, but rather thinking of massive bodies as bending and curving this thing that Einstein called space-time, if he was right, then you should be able to detect the movement of starlight passing near a massive body like the sun. And so to be able to detect this, you'd really need a very specific point of light, and it would need to be passing right near the edge of the sun. And so the experiment would be, okay, you map where the stars should be when the sun's not in that part of the sky at a different time. And then during the eclipse, you map the same stars. And if some of these, if the starlight near the edges has been curved, it would look like the star moved to a different spot. That's the basic idea. And so he actually made that prediction. Eddington tested it, confirmed it, and then astronomers have continued confirming it since then. But this is huge because it was a breakthrough discovery for cosmology, which really made cosmology in many cases a science, which some scientists doubted. Can you really talk about the universe as a whole? That's just one example. There's several other examples, including helping us unlock what stars are like, what stars are made of. And so you get this thing that's a really cool, we sort of think of it as a kind of, it's like a tag, right? It's sort of a clue that, okay, look really closely at what produces eclipses, the way it connects to both science and to life. And you're going to discover this remarkable correlation between life and discovery that we talk about in the book.
Isn't it also true that the existence of Jupiter in our solar system basically allows us to have life here, which I only recently, I can't remember now if I learned it from your book or from another book, but you might have mentioned it there. But like the idea that the existence of Jupiter, which is this large gas planet, and and somehow it though protects us and keeps, basically keeps. If without it, life probably wouldn't exist on Earth. So can you explain that a little bit, why that is?
Yeah. And so, I mean, most folks know that the Earth's the only planet that we know of in the solar system that has any kind of life on it. We, like to try to find it somewhere else. Haven't been able to do this. But you've got Mercury, Venus, and Earth. So moving from the sun. And then from Earth, you've got Mars. Then you've got the asteroid belt. Then you have these two gas giants, Jupiter and Saturn. Now, of course, astrologers have been telling us for thousands of years, I guess, that somehow these planets play a role in our existence. I don't really think their theory of how that works is correct, but it looks like they do play a crucial role because they are like sentinels. So, of course, our solar system, after Saturn, you get Uranus and Neptune and maybe Pluto if you count it. And then what you've got is all these comets. Okay, well, these comets are also part of the solar system. and they are in this kind of this very elliptical orbit around the sun. So they visit our part of the solar system, our neighborhood, every so often, and then they go way out like this. Now, those are cool to see in the sky, but you don't want large comets bombarding you, ideally. They have this unfortunate tendency to sterilize life on a planet. So imagine what would happen if we took these two gas giants, these big gravitational wells, out of the solar system. A lot more of those comets would visit our neighborhood and we would encounter it. As it is, they take a lot of hits for us. You can think of these gas giants, they're like the sentinels that protect the inner part of the solar system from too many comets.
And so there's like, one of the things I realized from this book is like the vast number of things that need to be true in order for not just life, but intelligent life to exist on a planet. And so we talked about like the moon, we talked about distance from the sun. Some of them are kind of like the habitable zone. It's kind of like, well, of course,
yes,
we wouldn't. I mean, where else would we live? We can't live anywhere else. So that doesn't like prove anything on one level by itself.
By itself.
Yeah. But then there's so many of these things. Like, what are some of the like kind of there's like different cosmological constants, like, you know, different variables. Absolutely. What are some of them that kind of make it where if they were just slightly different, we couldn't live here?
Well, so Guillermo and I in the book, we distinguish what we call sort of the universal or global factors, the things that are true everywhere in the universe. So for instance, the value of the gravitational force constant, it's the same everywhere. The four fundamental constants are, they call it the gravitational, the electromagnetic, the strong and weak nuclear forces. You think of these as forces that are relevant at different size scales. Simple kind of way to think of it. Those have to be very precisely set to have a universe that has, you know, planets, that has elements, that has galaxies. You change the gravitational force, for instance, the universe could expand forever and no atoms would be able to form, or it recollapse right after the initial expansion. So those are the universal things. And there's a bunch of examples of that. And then they're the kind of local things you need. So even in a universe fine-tuned for complex life at the kind of universal scale, you need, as I said, so you need the right kind of star, right kind of stable star with the right kind of energy. You need a rocky planet like the Earth, so it's gas giants don't work. You need that planet, as we said, to be the right distance from its host star. You need things like the large, well-placed moon. You need these planetary neighbors. The planet itself needs to be composed really basically Earth size, because it needs to be large enough to be able to hold an atmosphere, but not so large that it holds in things like a bunch of hydrogen. You need a liquid iron core like we have that's working the way it is to create this magnetic field around the planet, which protects it. You need the right kind of atmosphere in that planet. And then you need to be in the right kind of galaxy that has heavy elements, which astronomers call metals. I mean, so everybody that learned the periodic table, you know, in the 7th grade, so it's remember, it's hydrogen and helium and a bunch of others. And so what astronomers do, they will hydrogen, helium, metals, right? That simplifies it, everything else. Well, you need those things to build bodies, to build rocky planets. And so there's going to be an ideal place within the right kind of galaxy, not too close to the dangerous center, but not too far from the center, because if you're in the outer edge, it's mostly just hydrogen and helium. So there's a sweet spot, a galactic habitable zone, midway between the center and the edge of a galaxy, and probably between the spiral arms, which is, of course, where we are. That is just a kind of thumbnail sketch of some of the ingredients you need to build a single habitable planet. So when people say, well, the universe is so big, there may be 300 billion stars in the Milky Way, maybe there's 100 billion galaxies in the observable universe, this shouldn't be that hard. Well, that's true, but if you need lots of variables and each of them has a sort of small probability, you can very quickly swamp all of the probabilistic resources, certainly of our galaxy. And so we think already that it's unlikely there would be more than one habitable planet in the galaxy, just based on the kind of statistical calculations. So we treat it as an open question. Now, that's all the stuff you need for habitability. By itself, though, as you said, you say, well, maybe we just are the lucky recipients of a cosmic lottery. It was possible that it could happen somewhere. It's the one place it happened. The observers were looking around thinking, gosh, things look well suited for us. But our argument is that, okay, yeah, by itself, that's not a great design argument. But now what if I were to tell you that that also sets up the best conditions overall for doing science? So in other words, the most habitable places are also the places that are most science conducive. And what's the best explanation for that? Materialism doesn't have an explanation for it. Theism certainly does. If the universe is designed for discovery, this is exactly what we would expect. And in fact, that's what we argue for.
Yeah, I mean, that's a great point. And I think that's why I really think the value of this book is the kind of, there's not theological arguments in it, but it really does support a lot of theological arguments. I know, like, I've done a lot of reading of books in this genre that are, a lot of them are, as you know, are not written by theists, definitely not Catholics and not theists, although some are. And one of the things that you see is the recurring theme. I kept noticing it over and over in all these different books, is the prominence of the Copernican principle.
Yes.
And this is this idea, Copernicus is famously the person from the 16th century, the scientist, Catholic, by the way, of course, and who found that basically said that the Earth is not the center of the solar system, that the sun is. But then what's happened is that from this, there's this narrative, the narrative you hear, which is, we always thought we were the center of the universe and we're all that matters. And then all of a sudden Copernicus overturned that. And now we realize we're like nothing. We're not so special. We're completely like everybody else. And that has theological, anthropological, and theological implications. Definitely. Usually the argument is, therefore, we're not special. So and if we're not special, then there probably is nobody designed us, nobody created us. We just happen to show up here. And so explain a little bit from like how this works. And real quick, also, I've noticed in some Catholic circles, in Protestant circles, there's a reaction to that of, they actually start to say that the Earth is the center of the solar system because they recognize the problems of the Copernican principle. And then they kind of react to it. So what is like a better way forward for Catholics to kind of navigate this?
Yes. Okay. So the first thing is, I mean, we all know there was this kind of pre-Copernican cosmology. Anybody that's read Dante's Divine Comedy, he sort of presupposes it. But what's important to realize about it is, it's not like if you're going to find in the biblical text a description that corresponds to that, in which you've got these, the ideas is you've got this sort of Earth in the center. But Aristotle put the Earth in the center, not because that was the best place. His physics said that, well, that's where the heavy stuff falls. So the heavy, mutable, decaying stuff, it falls toward what's really the bottom of the universe. And then the moon and above, that's all made of this fifth element, this quintessence. It's immutable and perfect and unchanging. And so, in fact, prior to Copernicus, the Aristotelian Ptolemaic cosmology, actually, the Earth was a kind of, at best, it was a kind of intermediate place where death and decay took place. In fact, people talked about it as a place of detritus and decay. So the very meaning of the center prior to Copernicus wasn't that was the best place to be. So that's itself actually kind of a 19th century invention. And so, yes, what Copernicus did is he proposed kind of mathematically, he said, actually, if you treat the Earth as one of the other planets, and then put the moon at the stable center, it actually helped. You can explain the planet's movements across the sky much better. It still took really 100 years for this to gain wide acceptance, and more than that to actually really prove it. But nothing in Copernicus's theory or proposal tells us anything about our metaphysical significance. As I said, if anything, like Galileo, decades later, when he was arguing for the Copernican view, he actually said, no, this elevates us because now we reflect the light of the sun. He reinterpreted the center and the sun kind of more Neoplatonic lines. So it's not like you don't have to have a fight with Copernicus to disagree with the metaphysical claim that somehow science shows us that we're insignificant. But if you assume that, right, as a narrative, somebody like Bill Nye the Science Guy will always say this: oh, we're in this ordinary planet around an ordinary star, or ordinary neighborhood in the galaxy, in a universe, that didn't have us in mind or something. Well, ordinary compared to what? I mean, the thing we're most interested in the universe, what do we spend hundreds of millions of dollars sending probes to Mars for? It's to find evidence for life. So clearly, if you say, okay, well, if what we're interested in is a Earth or a life in a planet on which life can exist, gosh, we're really special. In fact, Earth is very, very unusual. I mean, we've discovered now, about 5,000 extrasolar planets. We have yet to find an Earth twin or even a Mars twin. And so depending on what you're counting, the Earth is profoundly exceptional and also probably rare in its properties. And so the Copernican principle, what it is, it sort of inspired scientists of the 20th century to kind of ignore these things, to assume that whatever happened here must happen countless times elsewhere. And it was really just in having to face the evidence over and over that, gosh, turns out you need a lot more things to go right in order to get life. But that has been the trend throughout the 20th and the beginning of the 21st century, is that we're just discovering that actually you need more than we had imagined just to get a single planet with life on it.
Yeah, and I think they start with the presupposition that there is no God when they come to this, because it's like, okay, if there's no God, then we have to explain somehow how we ended up with intelligent life. And so they do that. Now, what are some reasons? So I think what happens is like this idea of we're just an accident.
Mm-hmm.
But then, the fact is like from your arguments in Privileged Planet is this idea that we might be the only life in the universe. Now, this is a big debate about the existence of intelligent life or any life outside of Earth. And of course now we're talking a lot about like these congressional hearings with like seeing UFOs on Earth and things like that. Yeah. And I feel like that's mostly a distraction. Mm-hmm. But like the idea though, like how would you go about like your argument for whether or not there is intelligent life elsewhere in the universe?
We just treat that as an open question. Honestly, there's nothing about our argument that requires Earth to be unique. Now, our argument does strongly suggest that compared to all the kind of sort of planetary environments, the ratio of those planets that can host life is going to be very, very small. So Earth-like planets are going to be extremely rare. And so you can compare them in all sorts of ways with all these other places that you find. Now, speaking as a Catholic and so a theist, God could do this either way. I mean, he has lots of ways he could have done this. And so for me, it's an open question. Did God want life to just exist on one planet, or did he want it to exist in other places? There's nothing really in the biblical text that speaks to that, but I've never thought it was that big a deal theologically, because it's like, okay, well, let's just kind of wait and see. It's usually the atheists that are telling us, oh, if we find a microbe somewhere, somehow that's going to overturn all of Western Christianity. I mean, really? I don't think so. Ironically, in fact, if you're a materialist, you've got that's much harder. Look, if I believe as I do, that the universe, not just that God set things up, but that he's intimately involved, that the universe is intrinsically purposeful and teleological because of God, not in itself. But because of that, I think, gosh, if anything, that it's sort of easier to imagine life existing somewhere else. If you're a materialist, you're just dealing with kind of raw probabilities, and you've especially got the origin of life problem to face, which I don't think really has a solution in a materialistic context. So I mean, at least for me and for my co-author Guillermo, we're both Christians. I'm Catholic. He's a evangelical. We just feel like that's kind of an open question, and let's just perfectly fine and good that we want to look at that and try, because we're either going to discover that it's just harder and harder than we imagined to get a single Earth-like planet, which is amazing, or we'll discover that actually maybe there's some other places like ours. This is a prediction of our argument, is that if we discover other planets that have complex life native to it, it will be very, very much like Earth. In fact, it will look like Earth. It'll have water and continents. It'll be around the same kind of star. It'll have a moon. And Guillermo said, if we ever get a radio signal, for instance, from another civilization, the first thing we should do is send them our pictures of total eclipses and ask them to send us pictures of theirs.
It is interesting because the argument for decades, it seemed like, the Carl Sagan era was, well, there's probably trillions of planets, which is probably true. Mm-hmm. And, in the whole universe, trillions of planets. Well, the numbers just kind of, and so the first thought is, well, the numbers just work in favor of life, that, there's got to be on at least some of them. But then, like you guys go through a lot of the kind of the chances of the difficulty in having life.
That's right.
And what you find is like the very large number of trillions is kind of overwhelmed by the very small number, the very small fraction of what would allow for life to exist on a planet. And so they cancel each other out in one sense.
Yeah.
But you can't say, of course, we can't say for sure it makes it impossible. It's
That's
just
right.
simply saying it's going to be very, with our current technology, it's unlikely without being, if let's say there's intelligent life somewhere else, without some massively lucky guess, it's unlikely in our current technology that we'd actually find it because it just be so rare.
That's right. And now, because it's one of these things that's in philosophy of science, they talk about, okay, what is a scientific hypothesis? Well, it should be able to be tested against the evidence in some way. This is one of these claims like there is life elsewhere in the universe. That's actually almost impossible to falsify, but it would be easy to verify, right? Like if a ship shows up over in Washington, D.C. up here, right? It's like, okay, that settles it. And so it's clearly an empirical question. It's just that, based upon our techniques at the moment, we're detecting extrasolar planets of a certain size around stars. And of course, we can receive radio signals from space. And so at the moment, those are our only two ways of verifying that. Or maybe sending a probe to Europa, moon around Jupiter, and seeing if there's life there. But that's really the limit of things. And so we just said, okay, we're going to be agnostic about that question and make the risky prediction. But if we're right, we're not going to find planets that are much, much larger than ours around red giants with 12 moons. It's just so many ways that would mess up the hospitality conditions for life that we just think that's not how it's going to go.
So the Star Wars universe with all their crazy planets isn't really happening.
No, it's not. Even to get, life that's a planet that's mostly desert but could still host life, it's, not. Guess what? I mean, Mars is the most Earth-like planet we know of in the universe, and we've seen that.
It was kind of funny. I literally just watched Star Wars last week. A couple of my kids had never seen it before, so we're like, okay, you're old enough to see it. And it's kind of funny because when they were on Tatooine and Luke is looking at the two stars, at the two suns, I was kind of like, yeah, that's not actually happening. It's highly unlikely that it's possible that you could have life on a planet like that.
Oh yeah.
So thanks for ruining Star Wars for me.
Exactly, it does ruin it. I mean, because it's hard enough to get a stable orbit around a single star. Now imagine you got these stars perturbing each other constantly. It's just a mess.
One thing I thought while you're talking, just kind of an aside, I was wondering is, it seems like a lot of the money we're spending at NASA is for projects that seem to be geared towards finding life somewhere in the solar system, because we can't obviously go outside the solar system really. So we're just going to try to look in the solar system. Do you think that's kind of a waste of money? I mean, do you think we should be looking at something else, or do you think that's worthwhile?
I do think that's probably like, we want to send a probe to Europa, which is an icy moon. But it's under this very strong kind of gravitational pressures of Jupiter. And we think there is a liquid water sea basically under this ice. And so it's like, okay, well, that's one thing you need. You've got liquid water. Now, it doesn't really have much energy from the sun, but it may be getting energy maybe from something that's happening in its core. It's kind of an open question, but there's really only a couple of places that are at all plausible. Everybody recognizes now that Mars is pretty much off the table. And so the idea is that, well, let's go at least to the place in the solar system where there's liquid water. If we don't find anything there, I think everybody's going to realize, okay, this isn't worthwhile. But we do have that one place. And then there'll be Titan, which has an atmosphere, but it's a totally different thing. And methane, I'm not optimistic about it. So, I mean, that's why we spend a good bit of time in the book talking about Europa, just because it's kind of the best candidate. We give several arguments why we think it's still not going to be hospitable to life, but I don't think it's a waste of time because it does bear on this really fundamental question. And NASA started out, it's like any government bureaucracy, like right when it's implemented with a mission, it can do some amazing things. And so we got to the moon in '69, and then it became this sclerotic bureaucracy, unfortunately. But we seem to be able to successfully build satellites. So, I'm fine with that. It's going to be crazy if we keep looking in places where there's no prospects, though.
Yeah, I feel like the Europa Clipper, I mean, it'll probably find out a lot of things. And one thing it does do is if it finds no life, it kind of eliminates certain things. It tells us, okay, this is not a possibility for life in a planet or a moon like this. Okay, I just have to ask because I'm going to talk about something else here in a second, but I wanted to ask, like you mentioned about going to the moon. Do you think we're going to get back to the moon before 2030 like they're planning?
I think that on Musk's current trajectory, we will. I'm optimistic. Right. Now we'll have to decide to do it, and then he wants quickly to get to Mars. Right. And at the moment, I think that I have no reason to think that watching what's happening with SpaceX that we can't do that. In fact, I'm reasonably optimistic that maybe in the 2030s we'll get somebody to Mars. Now, I don't think Musk seems to think we're, I don't know, going to terraform Mars or something. It doesn't have the right atmosphere. It doesn't have a protective magnetic field around it. And so in fact, it doesn't even make sense to really send humans there. We should just send robots and stuff like that. The moon is a different thing, though. It's nearby. It is much smaller, so it's a lot less of a, it's much easier to get off the surface of the moon than to get off the surface of the Earth. And so setting up a subsurface base on the moon in order to use it as a jumping off point, I think that really, in some ways, that makes more sense than Mars. But Mars has this special allure because it's the closest planet to the Earth. And so it will learn a lot by sending someone there and hopefully getting them back safely.
Yeah, I think actually your book kind of shows this too, that I think I think Elon does too. I think they greatly underestimate the inhospitability, or whatever the word is, how inhospitable Mars and other places in space are. I mean, even the moon is very inhospitable too, but that kind of tells us how special the Earth is, because I've read things that say basically being in space for like a year or something like that is incredibly traumatic to the human body.
Absolutely. Yeah, you've got solar rays, you've got cosmic rays, and that, like small amounts might be fine. But like if you're on the surface of the moon or the surface of Mars, you don't have this magnetic shield that we have on the Earth. And so you're going to have to armor plate yourself or something. This is just not conducive to human life to do this long term. It's this idea that we're going to just have a city on the surface of Mars. I mean, it's going to be buried in a lot of heavy stuff. I mean, the only thing that really makes sense is you'd have something under the surface.
Yeah, and I thought somebody made a good point one time I read where they said, consider the most inhospitable places on Earth, like, for example, Antarctica or up on top of Mount Everest. Are we building cities there?
Nope.
No, because we know how difficult it would be to live there. So why do we think we'd build one up on Mars? It just is
those places are much better.
Way better.
Much better than any scenario on Mars's surface.
Yeah, I think we'll get. I wouldn't be surprised if we set up a base on the moon, simply because you can rotate people pretty easily. Yes, because it's only a few days once you get the hang of it. A few days between the two. Whereas since Mars, I think it's like minimum 6 to 9 months to get there, and that's only certain times of a 2 or 3 year cycle.
Yes.
You're stuck there if you miss the flight. You're stuck there for another 2 or 4 years. So.
I know. Yeah, it is. I mean, it really is. It's just exponentially more difficult than the moon is.
Yeah. But I think never underestimate Elon Musk, I guess. Though, right?
That's a good rule.
Don't bet against him. One thing that this whole topic brings up is the theory of evolution.
Right.
That. Because the underlying assumption, when you read a lot of the different scientists, like a Carl Sagan types, is that Darwinian evolution is 100% true. It's proven. There's no debate about it. And so the only way life happens is through this, and plants is a process of evolution. What is your guys' take on about how evolution affects both the existence of the universe, of life, and of intelligent life?
And so the first thing is that, like, we want to distinguish lots of different definitions of the word evolution. And so on the kind of super uncontroversial side, just the idea that the universe has a history, so that things change over time, that's a kind of non-controversial. Way over on the other side, I'll say the blind watchmaker thesis, which is the idea that everything in the universe and life itself is entirely the result of a blind and purposeless process. That's a kind of deep committed, The Blind Watchmaker by Richard Dawkins. All right. So those are the two extremes. And then you've got in the middle. So what I would say is, okay, look, natural selection and random variation explain some things in biology, antibiotic resistance, for instance, maybe variations in the thickness of beaks on the Galapagos finches, things like that. It's good at sort of kind of tweaking populations around the edges. There is no evidence that natural selection and random genetic mutations can produce the innovations that we actually see in biology. So I think that Darwin's mechanism is true, but it's also really a bit player when it comes to life. And that there's a lot more teleology and other stuff happening than we could possibly have imagined. Now, what about, sort of star formation? So I think it's much more plausible to say that, okay, given a giant cloud of hydrogen, and just the fundamental forces, and so you can have gravitational attraction, that you could get a star. I don't think that there's a type of innovation that's involved there in the same way that there is when it comes to life. And so in the book, we sort of presuppose that these physical processes are sufficient to account for these things. But we don't have, in my view, I mean, look, God could have just created ex nihilo this solar system 6 minutes ago, right? If he wanted to. He's not going to do that because it would be deceptive. But and so the way God has interacted across sort of cosmic time with the universe is, I'm going to sit loosely on the exact details, except to say that it's absolutely clear that there's purpose and teleology in these things. And we're perfectly happy to look at any kind of proposed mechanisms that people propose. But just as the Copernican principle has been distorted and manipulated to kind of tell the atheist story, so the Darwinian mechanism, which is interesting and explains a few things, gets way overused and is oversold to try to basically erase purpose and teleology from the biological world. And it just doesn't do it.
I know it's interesting because it seems like the atheists, especially starting in around the 19th century or so, they're just desperately like finding, okay, what can we find that will explain what we already believe? Okay, we'll use Copernicus as thing, we'll use Darwin, and we'll fit it in, we'll stuff it into ours. That's not really scientific, of course, to do that.
No, it's not. It's turning science into a kind of applied materialism, and that's the mistake. Natural science ought to be about a rigorous, the systematic search for the best explanations of how things work in the physical universe. No holds barred. We don't decide ahead of time that this hypothesis can't be true. And especially in the 20th century, like if you're a committed materialist, you had to say what Sagan did as late as 1980, that cosmos is all that is or ever was or ever will be. Well, in 1980, there'd already, for decades, the general agreement of the scientific community is that the universe hasn't always existed. It has an age. It has a beginning in the finite past. And so I think, if anything, 2024 is a really great time to be a theist, because we know from the empirical evidence that the universe hasn't always existed.
It's funny. I read Cosmos by Carl Sagan about maybe a year or two ago, and I felt like, okay, I have to read this because it's the book that everybody uses. And it's such a whopper, that first line, that you're just like, how do I even, I still read it, but it's like when the first line is such a whopper, just so factually, it's just a statement of blind faith is what it is. Yeah. Then it's like, okay, I know I'm getting into it at the very least.
No, absolutely. And of course he knows perfectly well that sounds liturgical. That sounds like the Gloria Patri. He's attributing to the created things, the things that should be reserved for the creator. But he also knew, he knew Big Bang cosmology. He knew the universe had an age. And so what I think that shows you is the kind of metaphysical pressure you're under if you're a materialist. You need an ultimate cause of explanation. It can't be outside the universe. And so you just attribute it to the universe. Now, these days, you attribute it to other undetectable universes and things like that. But that shows you that his commitment to materialism was so absolute, he didn't notice that he was articulating a doctrinal statement that was contrary to evidence that he in fact believed.
Yeah. It's funny now they're creating multiverses and everything like that. It's just, it really is just reaching and grasping for straws often. Now, one of the things in the book, I think you have a whole chapter on objections to your guys' points. And I feel like the first objection that comes into my mind when I read a book like this is that, okay, but you're limiting your definition of life so it fits in our existing universe. Couldn't there be life that thrives in a methane environment like Titan, or even crazier, like just on Mars or something, some type of life that we don't know about that is very unlike us. It could even be intelligent, but it just does that. It doesn't seem like you're kind of taking, okay, well, this is the universe we live in. This is what we, the planet we live on, we live now. Now it's only us. Couldn't there be something a lot crazier out there, life forms?
Yeah, in fact, we think that's the kind of crucial issue. We're not worried about it, though, because the thing I didn't say is we're doing actually what NASA does. So notice NASA is looking for liquid water. It's not because they are nearsighted and are narrow-minded and think, okay, well, carbon life like us needs liquid water. It needs a matrix for the chemical reactions. Carbon chemistry is most reactive over the same narrow range of temperatures over which water is liquid. So there's this kind of hand in glove fit. But as you said, well, maybe it's something based on a completely different chemistry. And so what you guys are doing is you're just assuming the only kind of life you can have in the universe is Earth-like life. Well, we're not just assuming it. What we're doing is we're assuming the truths of the periodic table of the elements. And so chemistry is basically a complete science at a certain level. All the elements are filled in. Naturally occurring elements in that periodic table. And we know the chemical properties of those other elements. And so it's not like, we sort of really haven't thought about it. The argument is basically in this universe, if you want organisms that have a chemical basis that can code information and store it, that can build complex three-dimensional molecules, can build three-dimensional bodies, there are just certain things you need to be able to do that. And there isn't a substitute for carbon chemistry, and there isn't a substitute for water. And so the premise of our argument is that, look, the same rules of chemistry and the same chemical elements, they exist everywhere we can see. It's not a different set of chemicals someplace else. And so what that means is you can actually constrain your understanding of what any kind of life is going to need just based upon our very robust knowledge of chemistry. And so that's why we're perfectly confident doing that. But it's important to point out that that's a premise based upon our knowledge of chemistry. At the same time, it's also a way to falsify our argument. So if we find native life on a completely different planet around a totally different kind of star, totally different chemistry, that's gonna just blow our argument to smithereens. And so it actually shows the argument's falsifiable. But that's the one I actually worry about in some ways the least, because I'm just fairly confident that it's hard enough to get a planet where you can have carbon chemistry and liquid water. The other stuff just seems like it's silicon or something. It's a distant second, and then there really aren't any other contenders.
Yeah, so basically what you're saying is there are certain laws of chemistry we know, we understand. There's certain laws of physics we know, and that's just the way things are in our universe, whether we like it or not, want to pretend it's not. And so in that limited kind of those boundaries, there's only certain ways that a life could actually form.
That's right. That's exactly it. And so this is why NASA's perfectly rational looking for liquid water, either on the surface or under the surface of Mars, but is not spending any time sending probes to the sun, for instance, looking for exotic life forms.
Yeah, that makes no sense. Now, you're involved with the Discovery Institute. I know it does a lot of the things kind of what we're talking about today. Can you tell us a little bit more about the Discovery Institute and like kind of what it's doing?
Absolutely. So Discovery is founded in 1990, co-founded by Bruce Chapman and George Gilder. In 1996, the Center for Science and Culture was formed, and it was really set up to create a research program, both of full-time fellows at Discovery, but also scholars, scientists, philosophers elsewhere, to pursue these very questions. So lots of books. Anybody that follows the intelligent design literature will notice in many cases that it ties back in some way to Discovery. So the books by biochemist Michael Behe, who's a Catholic, teaches at Lehigh University. Of course, the books by Steve Meyer, who's the director of the Center for Science and Culture. And so that's just one of several projects that happens at Discovery. There's also a transportation and a technology project and a homeless project. But that Center for Science and Culture is, you can sort of think of it as the kind of institutional home of the intelligent design movement. And in fact, Eric, since we're talking about it, I should mention there's a brand new book by a Canadian Oratarian, a priest, called The Catholic Case for Intelligent Design. It just came out. It is a really, really good book.
Oh, I literally just bought that.
Oh, that's great.
I haven't gotten it yet, but I just bought it at Amazon, I think, just the other day.
Cool.
Yeah, so I'm looking forward to reading that because I'm at an Oratorium parish, and so
Oh,
like I
wow.
saw as an Oratorium priest
Yeah,
who's like talking about this. I was like, oh, I gotta get this one. This is gonna be
absolutely.
great. So, okay, so I think we're gonna wrap it up here. Now, one of the things I want to do is encourage people again. The Privileged Planet. This is a 20th anniversary edition. You've added some new stuff, and
Yeah. We've
improved the
actually,
arguments.
yeah, we did. We added new information, of course, updated the data. We also actually rewrote it, so it's actually an easier book to read. I mean, you learn a lot of things about how to write in 20 years. It turns out,
Yes.
like, oh, I can't believe how I was right in this writing, 20 years hence. And so it is a big book, but as you see, it's got hundreds of illustrations, 20 pages of color plates and things like that. And so that's, it was a huge undertaking the first time. It was actually a lot of work to do the new edition, but we had, believe it or not, planned when we first started working on this book and got the contract from Regnery. We thought, oh wait, there'll be a 20th year anniversary edition in 2024. We should update it, and that is exactly what we did. So this was managed to do what we had planned to do over 20 years ago.
I mean, that's pretty forward thinking. You even did it, and you even nailed it on a year when an eclipse happened in America.
Well, and that's why we wanted, that's what we said, wait, 2024, there will be a total eclipse across the American continent. We got to do it then. So that's
great.
Yeah.
Yeah. So update, and now there's a website to dedicate to the book, privilegedplanet.com, correct?
Yes, that's right. And we're eventually, I'm hoping, going to have a large language model up and running so that people can actually ask questions, and it's trained on the book and other kind of adjacent stuff.
Ooh, that's awesome. That sounds exciting. I'll put a link to that in the show notes so people can, and I assume there's a place on that site that you can buy the book, right?
Yes, that's right.
Okay, awesome. Well, thanks, Jay. This is great. Where can people find out more about you're doing so many different diverse things. I know you're at Heritage Foundation, all that. Yeah. Where can people find out kind of the different work that you're involved in?
Yeah, I mean, probably the easiest thing is on X, formerly known as Twitter, which is my handle is at Dr. J. Richards. So that's sort of my real-time opinions. All my public policy work here at Heritage is at heritage.org, and stuff related to the Privileged Planet is at discovery.org.
Okay, awesome. Yeah, there's something I just lost my. Oh yeah, so I was just going to say I want to thank you. I know you guys at Heritage, especially you, have been doing a lot of stuff fighting against the gender madness that's going on right now, and so I really appreciate that because it's so needed to have like people who are dedicated to fighting that, just the insanity that's going on right now.
Absolutely, and I think, and we're winning it, Eric. And in fact, yes. 2025 is going to be an amazing year on that front.
Yeah, I like to think that too, because I really feel like I'm convinced that the whole transgender nonsense was like finally they took a step too far.
Absolutely. We know this. In fact, we know that something like 3 to 5% of the swing vote swung on this issue. So, and I knew that was what was going to have to happen for this ever to be bipartisan. And so, we'll see. If it's not, I still think we're going to have a successful year in 2025.
Yeah, I mean, Trump had ads that were explicitly on this issue. I remember when I went to a big conservative convention in Detroit, Turning Point, and Trump was there, and all the major people were Vance, everybody was there. I remember the thing that got the most consistent loud cheers was when somebody said something against the transgender movement. That was always got the biggest cheers, because it was just like, and you just talk to people, it'd just be like some mom with some kids, and she's not like really well versed in all this stuff, but she's just like, no, I just don't want that. I don't want them coming after my kids.
That's right. And it was a serious mistake on the other side to just sort of hitch their wagon to that star. But it violates people's natural reason and conscience. Even, unbelievers, if you have children, you have a natural inclination to protect your child. And this comes at, this ideology wants to destroy the family and destroy what makes the family, which is our capacity for reproduction.
Yeah. I mean, they were able to hide the damage of abortion, of gay marriage, and like that. You kind of can make that like that's for that's other people. It doesn't really affect me. But then the transgender is like literally right in your family. Yeah. And it's like, okay, I got to put my foot down here.
Absolutely. So. Yeah. They activated a lot of very accomplished and angry moms, and I don't think they accounted for that.
Yeah, you don't want to mess with them. Exactly. Oh man, when the mama bear starts just
Exactly. It's like you guys have no idea what you have activated, you know.
Yeah, that is one of the most powerful forces in the universe. That's the fifth, powerful force.
Exactly. That's the fifth fundamental constant. Yeah.
Yeah, exactly. The mama bear. Okay. Well, thanks, Jay. I really appreciate you being on there. And like I said, I'll put the links to Privileged Planet, to your X account, so people can follow what you're doing.
Great. Thanks, Eric. Good to be with you.
Okay. Until next time, everybody. God love you.